For over a century, the primary marker of human civilizational progress has been the systemic mitigation of friction. We design physical, cognitive, and social systems specifically to eliminate resistance and reduce the calories required to achieve an outcome. To understand the structural trade-off of this progression, we have to look at this model, Albert Borgmann's device paradigm. Borgmann noted that traditional tasks demanded direct physical interaction with the surrounding environment and the local community. Generating household heat required chopping wood, stoking a fire, and managing the hearth. The labor was physically demanding, but it embedded the individual in a continuous, active relationship with their physical reality. Modern engineering abstracts that labor entirely. We replace the wood and the axe with a dial on the wall. The device paradigm pushes the heavy machinery, the extraction, the refinement, the combustion, into the background. It strips away the environmental engagement and the physical skill, leaving the user with a pure, unearned commodity, instantaneous warmth. This engineering logic follows a specific trajectory. By removing these micro-obstacles, we assume we liberate the user's attention for more sophisticated pursuits. The removal of the chore is framed as the liberation of human potential. But empirical data suggests a different outcome. When we measure how humans actually respond to frictionless systems, we observe a phenomenon known as the tyranny of convenience. Borgmann identifies this as a systemic trade-off. Effort reduction functions as a corrosive force, chipping away at the cognitive and social skills that resistance once maintained. We can audit the exact costs of this erosion across three distinct domains: cognitive offloading, temporal compression, and social atrophy. Convenience is a highly active, path-dependent force. It alters the structural requirements for human self-reliance, engineering difficulty out of daily life at the direct expense of human capacity. The psychological mechanism driving this erosion is cognitive offloading. This occurs when an individual delegates mental processing to an external tool in order to bypass the biological limits of their own working memory. While offloading allows for faster, immediate problem-solving, cognitive psychology studies, specifically the pattern copy task, reveal a severe deficit in long-term retention. The brain defaults to complacency. Without an explicit, conscious goal to retain information, delegating a task to an external system completely halts the brain's encoding of new memory representations. The data is processed, but it is never learned. This micro-level psychological failure scales rapidly when high-stakes fields introduce highly capable automation. It initiates a process of professional de-skilling. This matrix catalogs the empirical findings of de-skilling across high-stakes professions. By tracking performance metrics when automation is either present, flawed, or suddenly removed, we can quantify the exact rate of professional degradation. In gastroenterology, physicians utilizing AI-assisted polyp detection systems suffer an immediate drop in clinical accuracy when the technology is withdrawn. Their independent adenoma detection rate drops from 28.4% to 22.4%. This specific failure is defined as monitoring complacency. The professional shifts from active, rigorous execution of a task to the passive supervision of an algorithm. We see identical degradation in radiology. When diagnostic AI presents erroneous suggestions for mammograms and chest X-rays, the human radiologist's error rate increases by up to 15%. They exhibit automation bias, overriding clinical training to follow the machine. In aviation, heavy reliance on autopilot systems actively degrades a pilot's manual flying proficiency. When a mechanical failure forces a critical handover back to the human, the pilot lacks the situational awareness to stabilize the aircraft. Transit data shows that while digital GPS navigation lowers a driver's physiological stress, it prevents them from building internal cognitive maps. They navigate the route, but their innate spatial mapping abilities degrade. The casualty in all of these scenarios is adaptive expertise, the critical ability to take existing knowledge and apply it to unfamiliar or highly volatile contexts. By engineering out the repetitive entry-level tasks, automation destroys the developmental pipeline. Junior professionals lose the training ground required to build deep judgment, leaving industries with a catastrophic expertise gap when novel problems arise. The second domain of the matrix addresses the temporal costs of convenience. We operate on the assumption that time-saving devices manufacture free time. This chart compares time diary data from 1965 to 2010. The bar graph shows that the absolute volume of free time for the working-age population has actually increased. Yet the overlying trend line indicates that the percentage of people who report feeling always rushed climbed from 25% to 35% over the exact same period. Sociologist Judy Weichman notes that convenience devices compress our expectations and fragment our schedules into dozens of intersecting nodes. Prepackaged food is a primary indicator of this fragmentation. The vintage TV dinner represents an engineered solution to a scheduling crisis. Its rise followed the breakdown of fixed institutional routines. As the traditional 9-to-5 gave way to more fluid labor patterns, the labor of cooking became a logistical bottleneck. As dual-earner households became the economic standard, families faced massive collective coordination failures. Convenience foods became the necessary patch to align scattered, misaligned time-space paths. Digital convenience accelerates this fragmentation. Smartphones replace temporal patience with an expectation of immediate satisfaction, driving a perpetual fear of missing out. Algorithmic variability in these apps mimics the reward schedule of a slot machine. This conditions users to expect immediate feedback, narrowing the window of tolerance for silence or waiting. This rewires our cultural status markers. Historically, abundant leisure time denoted wealth and aristocracy. Today, busyness and a conspicuous devotion to time-intensive, fragmented work serve as the ultimate signals of high social status. Optimization technologies inherently generate a subjective sense of scarcity. By making communication and transactions instantaneous, they continuously elevate the baseline expectations of how responsive a human being must be. The final domain of the atrophy matrix is the systemic dismantling of low-stakes public sociality. This network map visualizes what sociologist Mark Granovetter defined as weak ties. These are the casual, low-stakes connections we share with acquaintances, retail workers, and neighbors. The engineering of frictionless transactions actively severs these micro-interactions. When we optimize purely for transaction velocity, the weak ties snap. In retail environments, the introduction of the self-checkout kiosk transfers the physical labor directly to the consumer. Simultaneously, it engineers the casual human exchange completely out of the process. In the gig economy, algorithmic dispatch replaces human managers. This isolates workers behind app interfaces, replacing the intrinsic motivation of human accountability with sterile algorithmic benchmarks. Psychologist Sherry Turkle's research on hyperconnection proves that our perception of digital efficiency is a deception. Constant multitasking and digital offloading degrade a person's baseline ability to read human emotions. Frequent users of these frictionless systems exhibit measurably higher rates of social anxiety and depression. Convenience culture treats human interaction as friction to be eliminated. We purchase operational efficiency by liquidating our structural social capital.